Discrete random variables are a way to show a probability distribution where there's only a set number possible of outcomes, and then for each outcome we have a probability associated with it. So random variables can hold different values. We often use x to represent the random variable, and then it can hold different values. It can represent all of the possible outcomes for our sample space. So if we look at this example below where we have a cafe and they observed this distribution, what they did is each day they recorded how many cups of coffee they sold. And the idea is that, and this isn't very realistic, but there's only these outcomes. They either sold 30, 36, 42, 48, or 60 cups of coffee in a day, but no other instances happened. So with our probability distribution, it has to show all of the possibilities. But it's these numbers, 30 through 60 here, that represent our random variable. It's the possible outcomes for our distribution. And then for each case, we have a probability associated with it. So that's our probability of X down there. And the idea is that they saw 30 cups of coffee sold in a day. That happened 5% of the time. And 36 happened 20% of the time. 42 happened 25% of the time, so on and so forth. So where we have these possible outcomes, we also have these probabilities associated so that we can say, okay, yeah, we saw 30 cups of coffee in a day, but that only happened a few times, just 5% of the time. And then where we had the 60 cups of coffee sold, that actually happens a fair amount. That happens 35% of the time. So we end up with this distribution is this idea of likelihood of these values. So it isn't equal likelihood for these. So when we have a distribution like this, we can calculate expected value and standard deviation. So expected value, we use our symbol for mean, that symbol mu there. However, it's not just a mean. This is the idea of a weighted mean. It's a weighted mean because with these probabilities, when we make this calculation of the average, using the probabilities, we weight the things that happen more often. So we're going to see in this calculation is it's going to be heavier towards 60 and 42, and that 30 isn't going to hold as much weight as these other values because of that low probability coming through. To calculate our expected value, or we can use the symbol e of x, so it's the expected value of our random variable x. What we're going to do is add up our x values. So remember this summation symbol, that's just telling us to add. And then what we're going to do is take each of our possible values for our random variable times its probability. So what that's going to look like for our data set down here, we're finding our expected value, and we want to add up these x values times their probabilities. What you do is you look through each pairing. So our first pairing of 30 and that 0.05, so you take that outcome of 30 times 0.05. And then that summation symbol tells us to add, and then we go to the next pairing. So outcome of 36 times 0.2 plus outcome of 42 times 0.25 until we go through the whole set. And we get to 60 times 0.35. And just plug that into your calculator, and that should be an expected value of 47.4. So we can say is this cafe expects to sell 47.4 cups of coffee in a day. So that's how we calculate our expected value. Something we should check with our probability distribution, so like I said, this should be covering all of the scenarios. To know that it's covering all of the scenarios, a quick way to check is to add up your probabilities. So if we take 0.05 plus 0.2 plus 0.25 plus 0.15 plus 0.35, what you're going to see is if you add those up, it adds up to 1, which is the idea of 100% of our sample space. So if that added up to any other number, it wouldn't be an accurate probability distribution, and then these formulas don't work correctly. So probability distribution, probability should always add up to 1. So we found this average, this mean, although it's a weighted mean. Let's just compare that to what if we had calculated the mean the old way. What if we had just used add up the data values, divide by sample size? Meaning, what if we said, okay, we have these instances, the cafe saw these different days, and the number of cups of coffee they sold. What if we said, what's the average cups of coffee sold? Well, if we ignore those probabilities, then we'd be taking 30 plus 36 plus 42 plus 48 plus 60 and dividing by our sample size of 5. And if we had done that, the mean for this distribution would have been 43.2, which is lower than what we actually found. And that's because this mean right here, it's treating all of these numbers here, that 30, 36, 42, 48, and 60, it's treating those with equal weight. And that's where this formula is better, using this x times its probability, because it's saying, yes, 30 showed up, but it's not as valuable as these other numbers that have a high probability. So it kind of shrinks down the weight of that. And when 60 comes into play, it's saying, wow, that happened a lot of the time, so let's make sure this skews up towards 60. So where we could calculate a regular mean, it's not as accurate if we have those probabilities available. So this is how we calculate our expected value for standard deviation. To calculate standard deviation, and there's our standard deviation symbol there, sigma, or you can write SD of x. You're going to have this big square root symbol. So part of standard deviation is taking a square root, and then we're adding up. And this part right here is the idea of deviations squared. So remember, deviations are when we take our data value minus the mean. So we're trying to get this idea of the distance between what we observed and what is expected. So for us, it'll be this idea of taking 30 minus our mean, 36 minus our mean. So finding these distances and then squaring them because we need positive. Now, since we have these probabilities available, it's like this is a weighted standard deviation. So where 30 is pretty far from the mean, so that 30 minus 47.4 is going to create this big difference. But the probability is so low, so when we multiply it by its probability, it weights it in that way. And when we get to 60 and take that 60 minus 47.4 squared, it gets weighted that one happens a lot. So this standard deviation uses that probability to weight how often that distance squared occurs. So, standard deviation. So what we want to do is we're going to have this big square root. We're going to add up those deviations squared and then multiply each of them by their probability so that we weight them correctly. So with this, I just start off with a big square root symbol. And this one gets a little long here. So we're going to start off with how 30 deviates from the mean. So we take 30 minus that mean of 47.4, square it, then multiply it with its probability of 0.05. Then we can add on the next one. 36 is our data value, minus the mean squared, times its probability. And then 42 times its probability, and get these last two down. But notice the mean stays the same for each of these. What's changing is the data value and its probability. And the last one's that probability of 0.35. So this is what the full calculation would look like for standard deviation, where with other sections we can use technology to calculate mean and standard deviation. For us, it's a little trickier here. There are tricks in Excel to kind of set up a spreadsheet to calculate this for you. Really, it's better to just kind of write it down and plug it into the calculator like this. Just be careful with your parentheses and making sure things are squared. What you could do is kind of do piece by piece. Just be sure that you round far enough. Go to 4 decimal places. Go to even more if possible, just to make sure you get it as accurate as possible. So when we plug this into the calculator, we should get out 10.2. So what this tells us, using that expected value, using that standard deviation, is we expect to sell about, I'm going to round that value to a whole number since they're cups of coffee. So we expect to sell about 47 cups of coffee. And on average, that deviates by that about 10 cups of coffee. So that's how we calculate mean and standard deviation with this probability distribution. So probability distribution, you always have two pieces of information, the possible outcomes and their probabilities. And both values should be numeric. So you have numeric outcomes, numeric probabilities. Those probabilities should always add up to 1 to represent being the whole sample space. And then we have these two formulas to use to find expected value and then to find standard deviation.